Hi guys, so I've got something a little different here now. I've got a circuit here I've been working on. It's it'll pulse both sides of the motor, or the poles on this. Every magnet will fire, and it'll flip the polarity because these are north south. So here's the output for the motor. These are the inputs from the two batteries. Each has its own separate input. This is the output right here. These green and yellow go to the LEDs here. This is some current meters I have hooked up right here. I've not really tested this yet. I've only ran it for a couple minutes to get it set up. And this is going to be the first test. So here, that meter here will have the voltage of that coil back here. It's just a coil that's on there. It's not under load or anything. It's going to measure the AC voltage and the frequency of it. The battery's almost dead in my meter, but that doesn't matter. And something else I was going to say. Oh yeah, too. I can make this circuit if I had some good PNP MOSFETs that are just as good as these 44s. I'd be able to make this circuit run with just one input battery and one output. But without those FETs, because I need to fire both sides, the positive and the ground, to be able to make that circuit. I can do it, I just don't have the FETs. I've tried lots of PNPs, but they don't work. They work, but they don't give you the results that the NPNs do. Not even close. But I'm going to start the motor up anyway. So on the scope here, I'm going to measure the voltage. It's hooked up right here on the motor coils. So just do a little bit of, and an underneath thing too you'll see is even with just one input, both outputs come on because they're hooked to the same. Right here, it's like they get a vibration going, so the outputs both turn on at the same time. So it's not that one touching the magnet, so turn on this one. See they're both on. Here's the current for it. There's a scope. You could see this is higher or lower, so this is the input up here and this is the output. The LEDs are about the same voltage as the input where they run at, so that's why these are equal-ish. The output's a little bit higher than the input. So you've seen that side start up. Let's just try the other side. Side's pulling a little more current. So it gets going. But you can see they're still both on. And now I'll turn the other one on. Now you can see the scope, how they're both going. Now if I expand this out, you can see what they look like together. They're pretty close to the same. This one's not quite firing as good as this one. They're pretty equal though. They're pretty close. You can see like this is the input on this side and that's the output here. And on this side here, this is the input and that's the output. Fly back. So it's kind of, you can see it here a little more. Flyback is higher because this is the zero line. The input is here, this is the output. Input, output. on the frequencies about 4,300. 4.3K on each one. So I've done this circuit a lot with the single input battery and output battery, like years ago, way before YouTube. And I always use commutators for it. It was easy to make. It's really simple actually by using commutators. The motors weren't small like this though. They did work. The reason I need the PNPs is because I need them to switch the positive side. So way more complicated, but I need the parts to be able to build it. And I don't have those, so it's not even worth it. Till I can build a single-sided PNP switching driver circuit like I have with these other ones. I'm not going to waste my time on building this one because they have to be able to switch the same. If they're not switching at the same speeds, it's not going to work. But yeah, works awesome. Once I find those PNPs, then I'll build that other part without and bring it down to one battery on the input and one output. But until I can find those, I still have to run it like this. This just makes it a lot better now because you can use just the one coil for the whole motor. Like you put more coils now and run the whole, like on every magnet, you know. It's like having two driver circuits, but no, you don't have to, you know, you can just use your coils more efficiently. You still get the same flyback out. The output's really good with it. I'm pretty sure that's how Newman's motors were working. Was he had a commutator that pulsed multiple times per coil, per pole, and then he flipped the polarity and did it again. And that's what this is doing. You got how many pulses here every time the magnet goes by. Let's just count here. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 ons, 18 pulses, and 18 flybacks. You know, if you're trying to run the motor with just one on and one tiny little flyback, you're not going to do anything. You get some pretty decent speed with the rotor, but I can do that just as good with this. That's why you need to pulse it. PWM, your input, not just steady on and off. Doesn't matter how fast you're turning it on and off, it's still you may as well just pulse the whole duration of the magnet going by with multiple pulses. Like that's what you're trying to do by turning it on and off real quick with just one magnet. It's not very good. You get hardly any rotation out of your motor like that. This could be done with opto timing too, but you need to make 2 discs, and it's incredibly complicated to try to make a disc that's exact timing that you need for your frequency. Like, you would never be able to make a disc that does this. Gives you 14 on and off. You'd have to combine it with this PWM to make it work. And even then you're looking at, there's 16 magnets on here, so you have to have 2 discs with 8 on and offs on each one. That'd be precisely to match your magnets. And every magnet's different. Like, the strength of a magnet varies for magnet to magnet. Whereas the Hall effect is working by the magnet. It's not working by a steel disc. It's the magnet is what's telling it to turn on and off, not the disc. So this works pretty good though. See, change some frequencies here. Bring it up. This should fly now. Some of these pots are junk. Brand new, but they still do what you're seeing here. Got a batch of shitty 50K pots. Yeah. Works good. There's lots of air blowing off that. So you can see now there's less pulses because I've changed the frequency and the duty cycle. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 and a half-ish. This one even has less because I don't have them equal. 1, 2, 3, 4, 5, 6, 7, 8. You can see how much further down the output is compared to the input. And they're pretty equal. Pretty happy with that. Worked out good. But there'll be more coming with this circuit anyway, with some different motors and stuff like that, as I refine it a little bit more. This was just made in my head. I don't have any drawings or schematics of it, so I can tell you right now the only difference is right here. You need to have a Schottky diode right here on each of your driver circuits. And that's all that's different. And then, you combine the loads from 2 driver circuits. Your second driver circuit will have its positive going to the negative of this one, and just opposite where you hook them up right here. And then your outputs will go separately if you want. I'd keep them separate. That way you can measure differences. And that's it. Shit, I hope you guys are seeing that. So the Schottky goes here, facing, so power can go through it this way and can't come back in. and you need 2 of them on each driver circuit. One on each driver circuit, 2 in total. And your second driver circuit positive will go to where this negative is, and negative will go to where this positive is. And it's the only thing that's different. But thanks for watching, guys. It's been good fun building this one.